All right. Happy Friday, everybody. Welcome to the 5th Annual Puget Sound Green Infrastructure Summit. I'm Aaron Clark from Stewardship Partners, and I'm really excited that you could join us today for installment 2 in our 9-session series of summit presentations. Today's session is Big Ideas Outside the Box, and we have some great speakers. And I want to go ahead and get started with a land acknowledgement. On behalf of Stewardship Partners and the Summit Host Committee, I would like to acknowledge that we are all on the traditional land of the first people of this region. Tacoma, where the summit was originally scheduled to be hosted, is the traditional land of the Puyallup tribe, and we honor with gratitude the land itself and the Puyallup tribe, who have been faithful stewards of the land, water, and ancient history of life there since time immemorial. From where I'm sitting today, I want to honor with gratitude the land of the Duwamish tribe in Seattle as well. And many of us are attending the summit from other parts of the region. If you do not currently know on whose traditional land you work and live, we encourage you to find out. Please take a moment to acknowledge with gratitude the land where you are and its first people. I also want to just do a quick thank you and acknowledgement of our sponsors. Boeing and King County are title sponsors, and I will not name each of them, but I want everybody to see why and how, with so much support, we've been able to pull this event off, planning it twice and pulling through a virtual version. So many thanks to our generous sponsors, and also a huge thanks to our host committee, ECOSS, MIG, Nature Conservancy, Pierce Conservation District, Puyallup Watershed Initiative, the Russell Family Foundation, and Wazoo. You guys are amazing. Our advisory committee has been a great help as well. And of course, my heroic team from Stewardship Partners, as well as I want to acknowledge Cascadia Consulting, who have been able to pull this thing together amazingly. Their logo should be there, but we'll make sure and get that on next week. A little guidance for successful webinars. You know, we're trying to make sure that this is a human event. It's sad that we're not in one room together, that I'm staring at a screen and a little web camera instead of all of you and your faces that I love to see so much. But as we muddle through this, you know, we just ask for patience with technology, and we especially ask for patience with human realities. If you see a naked child run through my background, lucky you. And, you know, I guess we're offering a prize for whoever has the most awkward or embarrassing or impressive family invasion during a presentation. So to the winner of that goes a Stewardship Partners lapel pin. All right, the gauntlet has been thrown. This is a Zoom webinar. So first off, this is being recorded. You will notice that these are being distributed through Stewardship Partners YouTube channel. You can search for it. It doesn't show up right away when you Google it, but it's up there, and we'll share a link as well. So this one will go up as soon as the video has been processed, and you'll be able to go back and watch all your favorite moments. Everybody who is here as an attendee has their video turned off and their audio muted. And we will, the only people speaking and on video will be the presenters themselves. We'll start with presentations, and we'll have a few questions in the middle of this session, and then Q&A from the audience at the end. And you will use the Q&A button at the bottom of your Zoom window to ask those questions that you have for panelists. If you have a technical question, use the chat function. That will be dealt with and responded to by one of our team members to try and address any glitches that may be occurring for you, whether it's audio or video or something of that nature. And when it's time to leave the meeting, or if you have to leave the meeting, there's a little red button in the lower right corner of your screen that will get you out of the meeting. And with that, I'm going to hand control over to Ryan Mello. Ryan Mello is one of our esteemed host committee members, executive director of the Pierce Conservation District, a good friend, a visionary and leader of our region. And with that, Ryan.
Thank you, Aaron. Aaron, thank you for the amazing leadership that Stewardship Partners provides year-round for all of us in this space, and everything you've done to make this web series happen. I know we all love working with you, but you put a ton of effort into driving innovation. So thank you for Stewardship Partners and your leadership in particular. I'm really excited for the next little less than an hour we have to spend over the lunchtime together. We've curated for you some of the brightest minds in the for-profit, nonprofit, government, non-government sectors, doing some of the most innovative, groundbreaking, no pun intended, things related to green infrastructure. So we're gonna get right into it because we have a lot of big ideas to share and learn together. First up is Cari Simson. Cari is a project director focused on stormwater at ECOSS. ECOSS, if you don't know, Environmental Coalition of South Seattle. They renamed themselves and rebranded as ECOSS. She joined last year, but she comes with years of experience in project development, project management, and helping the for-profit and the public sector really innovate in this space. So I'm going to hand it over to Cari to take us through our first presentation. Cari.
All right, thank you, Ryan, for that very nice intro, and thank you, Aaron and Lynn and everybody. So yes, my name is Cari Simson. I work at ECOSS, and ECOSS staff actually speak 12 languages and provide education and technical support for all kinds of green infrastructure, including the Rainwise program, the GSI mini grants, which Stewardship Partners also will help administer, and other green infrastructure consulting work. And additionally, ECOSS staff will be hosting webinars similar to this for the industrial general stormwater permit, the IGSP, and the municipal stormwater training this spring. Instead of an in-person meeting, there'll be webinars. So if you're interested in that, you can check out that information on our website at ecoss.org. So today I'm going to share information about the Equinox project demonstration site. ECOSS really works in tandem with businesses to raise awareness about innovative nature-based solutions that mitigate flooding and stormwater pollution. And I too want to acknowledge that our project site is on Duwamish land, and the Duwamish tribe and indigenous people are working very hard to improve health and the environment. And so just wanted to acknowledge that. So advance. Oop. How do I advance the slides? Sorry.
Use your arrow. There you go.
Oh, there we go. Okay. So as we know, all of us know, polluted rainwater runoff is the leading source of pollution in Puget Sound. This is actually a screen grab from this great video that Nature Conservancy made called Solving Stormwater, and I just thought it was cool to see the chemicals on the roof, which is really what our project is focused on. So the chemicals in runoff have been shown to kill coho salmon in less than 2.5 hours. And in most industrial areas and all over our urban areas, the pollutants come from vehicles, industrial activities, aircraft, and other sources, and are then deposited on roadways, roofs, and other hard surfaces through air deposition. And in most areas that of our built environment, when it rains, those surfaces are washed, the chemicals are then washed into the nearest water body. So businesses need solutions to support stormwater pollution. Oop. Oop, there we go. So this is the project site, the before picture. Oops, hold on, back up. I think there's a delay with my arrow. So businesses need solutions that work in densely developed areas without open space. Oh no, I'm going wrong way. Go back. Okay. So a lot of the industrial areas and big commercial areas lack space between buildings, between the property line and the public right-of-way, lack of parking and freight vendor access, There's stormwater compliance issues there. Unimproved roadways, as you can see, there's no curb or gutter. There's only one storm drain on this entire street of 5th Avenue South. The large roofs, as we said, collect all those pollutants and they just wash out into the street or in the yard of businesses that have like a maintenance yard, or and then that becomes the responsibility of the property owner. And I just want to point out the irony of this exact area is this area of Georgetown, more than 100 years ago, was in the middle of 5,200 acres of mud flats and salt marsh and riparian forest, which did act as that natural sponge and filter for stormwater. And in 1913, when the Duwamish was dredged and straightened and industrial land was created, it basically paved over that land. So below the buildings and paved surfaces is some of the best draining soil in King County, but unfortunately it's capped by pavement. So, and today actually this site, because it's so close to the Duwamish River, when the Duwamish River is at high tide and it's been raining, the catch basins and drains that go to the Duwamish can't drain, the groundwater can't drain. And so we actually have had flooding on the street, which is why we had this hilarious picture of some of the Equinox artists in a canoe on 5th Avenue South. So that's the kind of site constraint that we have going on. The Equinox, I'm actually gonna go, I don't know why it's a delay. Oh, there we go. Marquee Machinery is a project I worked on back in 2009. I don't think I'm gonna have time to talk about it today, but this was the first kind of industrial strength GSI project. And I encourage people to check that out. I can give you the address to go look at it. So Equinox Studios is located at 5th Avenue South and South River Street and has 125 artists who now have 100% ownership. So as tenants pay rent, they actually gain equity. And the goal of the whole place is to create a sustainable, affordable arts community in Seattle. And in 2018, ECOSS started partnering with Equinox to create this large scale GSI demonstration site, because there's 100,000 square feet of art space inside, but 62,000 square feet of roof area on all the buildings that the Equinox owns. And so we thought this is a great location to showcase and test out different types of green infrastructure. Because of its proximity to industrial businesses in the Duwamish, anyone could go look at them on their lunch break or after work. And we just thought this is like a great visible way to share this information. And also because Equinox is such a large arts complex, like over 18,000 people go there every year for public events. And again, this is a great way to kind of educate artists and other folks about how green infrastructure works. And ultimately 1.3 million gallons of roof water will be passively filtered once this project is complete. So phase 1, which we just completed this winter, includes capturing most of a 7,000 square foot and 3,000 square foot building. So there's 2 buildings. We've mostly captured that whole roof area. We hosted 2 learn and do workshops for rainwise contractors. We built 4 Gradix boxes and 2 oyster shell downspout filters. And Equinox, Sam Farzano, the owner of Equinox, physically with his a backhoe, constructed permeable asphalt, permeable concrete, and pavers. And then there'll be a deck with a water catchment system. So this is like part of a larger project. And these pictures show kind of the 2 of the workshops that we hosted with Rainwise contractors on the top and Port of Seattle staff with ECOSS staff on the bottom. And I'll talk more about these 2 systems on the next slides. So Gradix boxes, for those that aren't familiar, are basically a giant rain garden in a box. And you can make them out of a lot of different materials. You can see the top right picture is basically a big water tote. You cut the top off, you change the bottom drain a little bit. You put a piping system inside in the bottom and you fill it with gravel, cobbles, sand, soil, and then plants on the top. And the one on the bottom was actually fabricated by Equinox. It's a steel container with a drain coming out the bottom. And these basically connect right under a downspout. It's like it's excellent for businesses that don't have any open space for any kind of rain garden or some other kind of facility. So at the Learn and Do workshop, we had 2 Rainwise contractors, one who spoke Vietnamese, one who speaks Chinese as their first languages. And they were learning along with ECOSS staff how to build these, and we built them together in a day. So it was really exciting to do that. And we plan to do more of these Learn and Do type events now that we have the knowledge that we've learned that, or figured all of this out. So the second technology that we've built is an oyster shell cistern. And this I had never even heard of, but found information from the port that they've been using this to mitigate copper and zinc on their own properties in their stormwater. And coincidentally, ECOSS rents an office space from the port, and one of our buildings has 20 oyster barrels around the facility. And so I suddenly like put all this together and contacted the port, and their staff came and taught us how these are built. So essentially it's a cistern filled with oyster shells. The shells naturally adhere, the copper and zinc adhere to the oyster shells, removing those heavy metals from the water just as it's filtered. So it's like a Brita filter kind of. So the port has done several years of testing and has found a 41% decrease in zinc and a 33% decrease in copper after they put these systems on their buildings. And so we did pre-testing last year before this whole project started. We're going to do post-testing in June, and we hope to see some results to share with people of the percent decrease. And again, the Port of Seattle staff, which is the bottom picture, came out and showed us how they made them, and it was like a great hands-on activity with Stone Soup Gardens. 2 of their staff were helping do the work with us that day. So the last kind of collection of technologies at Equinox is permeable paving. And I know some people are familiar with this, but just so you can see in this top right picture, there's permeable asphalt, then permeable concrete, and then pavers going away from you. This picture on the top left is a 6-inch thick permeable concrete, because this is a loading area and they really wanted something to stand up to, like big trucks that would be coming in and out. And then the bottom left and right, you can see the paver guide, which is basically like a tray that the pavers sit in, and then the water can flow through the tray into an underground cistern, which is going to hold 4,800 gallons of water, which will then be used for irrigation. All of this has just been kind of the brainchild of Sam Farzano from Equinox, and then partnering with ECOSS to do the fundraising and the kind of education and everything. So this is really to transform his space, or this artist's spaces, to be more sustainable and do this education. So the paver guide system is one of the Pure Blue, one of their technologies that they work with their innovators to promote. And so if you want to learn more about paver guide, there's a link right there to check that out. So for next steps, we are going to do the water quality post-testing in June, or probably May, while we still have some rain. Because of the stay-at-home order, we wanted to do public tours already, and we obviously haven't been able to do that. So we're going to do some video tours and post those on social media and link to everybody who's been part of all this, so you can see them and have we'll walk through how each of them work. Equinox and ECOSS will be building the next phase, which are these EcoBoxes, which are really large rain gardens in a box, like Splash Box and some of the other kind of big, and those will capture the rest of the large building that I talked about. And then we're going to build a vegetated wall that will use the harvested water for irrigation. So eventually that whole complex of arts buildings will be really transformed. So that is our blazing fast overview of the Equinox project. And just to wrap up, I mean, I think this project demonstrates how we can support businesses who are seeking low cost and out of the box thinking to address challenges on their sites. I think businesses have been somewhat left out of the green infrastructure revolution because of their site constraints, and I think this is a way to bring them into the fold. So I encourage, if anyone has commercial or industrial business partners that they think could work with ECOSS, please reach out and get in touch with me. We're looking for a few early adopters who would want to do this in the Duwamish area. The other thing to mention is that there are going to be green mini grants, GSI mini grants available specifically for projects in the Duwamish coming from King County's part of the Superfund cleanup. So King County is providing money to be handed out as mini grants. So there is an opportunity for funding for people that want to do this. So I just want to give a shout out again to the funders, Boeing Company, King County Flood Control District, BNSF, and then Aspect Consulting providing engineering services at a discount, the Port of Seattle, King County Wastewater Treatment Division, and Pure Blue for technical support for Paver Guide. And then we also received a grant from Puget Sound Stewardship and Mitigation Fund, which is a grant-making fund created by Puget Sound Keeper Alliance and administered by the Rose Foundation to do the water quality testing and reporting. So thank you very much.
Cari, very interesting, practical application in really tough constraints. So thank you for these great ideas. You know, what's really awesome about green infrastructure is not only is it practical, right? People, these, as you showed, these places where these businesses had to operate were turning into lakes, and that's really difficult to operate in. But so not only does it make it so that their businesses can function, people can park there, walk there, etc. But there's also financial incentives often for doing these already practical things. What kind of financial incentives quickly are you aware of? You mentioned in the Duwamish, but are there financial incentives outside of the Duwamish?
Yes, and actually the GSI mini grant program that Stewardship Partners helped launch with ECOSS providing some of the outreach and technical support, we will have a renewed funding cycle for that starting, and that's for any property within King County's wastewater treatment boundary. So unfortunately, it's just King County, but we are working with, I believe, Pierce Conservation District and Snohomish Conservation District to try to see if we can do something regionally. So that is a potential down the road that the 3 counties conservation districts could have a fund for something like this as well. But I do think this is totally fundable and would really help businesses right now, you know, who are in some cases struggling, like their business is upside down right now from what it was 3 months ago. So, so yeah.
That's awesome. There's at least one question I see in the chat, and actually 2. So folks can watch that as Cari answers some more specific questions in the Q&A box in the lower right. Thank you, Cari, for doing that. In the interest of time, we're going to move on to our next presenter. It's a team, and you know what's really awesome is oftentimes we get to see some interesting ideas of specific sites. The next team is going to talk about more regional landscape kind of scale green infrastructure. So excited to think at a different scale for a moment. We're going to hear from a team who's worked together on doing this kind of work. Brian Mickelson is with Seattle Public Utilities Drainage and Waste, with the drainage and wastewater line of business. He's the policy lead for Seattle Public Utilities Green Stormwater Infrastructure program. He also leads work to develop cross-sector partnerships, public-private partnerships, non-government, et cetera, to leverage investments in green infrastructure and better drive multi-benefit outcomes. And his teammate today, who's worked on this kind of landscape scale work, is Puja Shah, who's an associate with KPFF Consulting Engineers. And Puja has been practicing as a civil engineer in Seattle for 20 years. She has a great passion for stormwater management and its role in protecting the waters that surround her life here in the Salish Sea. So Brian and Puja, let's kick it to you.
Thanks, Ryan. Can everyone hear me? Great. Thanks for the great intro, Ryan. I'm excited to be here. So as Ryan mentioned, my name is Brian Mickelson. I'm a strategic advisor with Seattle Public Utilities in the drainage and wastewater line of business. I work on green stormwater infrastructure policy, and as Ryan mentioned, sort of help us think about how we can form partnerships like the one we're going to talk about today. With me is my colleague Puja, who, Puja, do you want to just say a few words of intro?
Sure, yeah. As mentioned earlier, I've been working in Seattle for about 20 years now. I've had some really amazing opportunities to help form what our city looks like, but this is really the project that we're about to talk about is one of the projects I'm most proud of and most excited about. So I'm really excited to be able to share that with you.
Thank you, Puja. Let's see what kind of delay here we have here. Not too bad. Okay. All right. So I'm going to talk through this outline. So we have a little bit. We're going to do a few introductions of our organizations and set the context for how we kind of came into this partnership. We'll talk a little bit about the different components of the partnership with the University of Washington, and as Puja mentioned and Ryan mentioned, sort of the opportunity to look at things at a more regional scale, look at stormwater management at a basin-wide scale, and then we'll talk through the specifics of the partnership itself and the GSI facility that is going to be designed on campus. And then we'll talk about associated benefits of partnering. So thinking about environmental benefits to the receiving waters, the benefits of the project and the partnership as an education tool to UW students and to the public at large, and how the team is approaching the partnership sort of through a spirit of collaboration. And then questions at the end that we'll respond to in the Q&A. So Seattle Public Utilities, we're responsible for managing the city's drainage and wastewater system. That includes overseeing the Seattle Stormwater Code and the associated Stormwater Manual. That's something we work in partnership with the Seattle Department of Construction and Inspections to enforce. On the GSI front, SPU has been at the forefront of GSI innovation for 20 years now. We have a lot of experience building GSI, predominantly in the right-of-way through our capital program. The latest of which you can see through our natural drainage systems partnering program, which we do in conjunction with SDOT to try to get sidewalks built while we're building drainage infrastructure. We also partner with King County, as Cari mentioned, on the Rainwise program, and that offers rebates to private property owners, predominantly residential, for building rain gardens and cisterns to manage roof runoff. So right now, SPU is in the middle of the next iteration of our GSI program. We're expanding, we're continuing to grow and accelerate the use of GSI and thinking about ways that we can do that. A key focus for us is, as Ryan mentioned, sort of forging those innovative cross-sector partnerships to support sort of a broader set of outcomes, environmental or social or economic. We want to leverage investments that are already being made outside of the city context, and I'll talk a little bit about that in a second. And we really want to expand the suite of tools that are used. We want to advance the industry itself. So what I think this partnership sort of touches on all three of those things, and we'll talk more about that as the presentation progresses. So just a little bit more context setting. Many of you watching probably know, but in 2013, the City Council, Seattle City Council, and the mayor directed city departments to work together to achieve an aspirational goal of managing 700 million gallons of stormwater a year by 2025 using green stormwater infrastructure. SPU is the lead department for that work, and we report out annually what our progress is in trying to reach that goal. This graphic shows our progress to date in working towards that goal. And on the right, you'll sort of notice four main buckets for how we think about how GSI gets built. They include the city capital projects that I mentioned through the Natural Drainage Systems Program, for example, projects through incentive programs like Rainwise or the King County mini grants that Cari was talking about, voluntary projects led by community, and then development projects that are delivered through stormwater code requirements. So you'll note that a pretty big share at the beginning, sort of 20 years ago, when GSI was really starting to take off, it was, you know, predominantly SPU led, and over time, the share of the projects led by the city has fallen. And I think it's really important to think about the importance of partnership in this context. So when you're talking about stormwater and collaboration, you know, in this context, it's about the code. It's about UW building a project, and then us thinking at a regional level about how we can optimize water quality outcomes at the basin scale. And so Puja is going to talk a little bit about that, and I'll pass it along to her.
Great, thanks, Brian. So what you're looking at here is an overall map of the University of Washington's main Seattle campus. KPFF and the UW have had a really long working relationship. The purple figures that you see here are projects that KPFF and the UW have collaborated on together over the years. So we've really got a great relationship with them. What you can also see in this figure is that there's water surrounding so much of the university's campus. And KPFF's main office is in downtown Seattle. So, you know, we get to enjoy this water that surrounds our city every day. And the exciting part about all this is that we're also in a really amazing position because we get to really take part in providing the protection that these waters need. So having the UW on board as our partner for this endeavor was really important to us. Go to the next slide, please. So this is a breakdown of all the drainage basins that the university campus is broken up into. This is an exhibit that KPFF originally put together when we were helping the university with a planning exercise about stormwater management. Highlighted in blue is the San Juan drainage basin, and that's the drainage basin that we're going to be talking about a little bit today. This is about a 34-acre basin, and the regional GSI facility that we are designing is going to treat runoff from the entire basin. And the next slide, we'll zoom in a little bit on the part of the basin that we're working in. You'll see the red rectangle in the middle of the screen. That's where the UW Health Sciences Education Building will be constructed. And that is the project that enabled us to move forward with this regional GSI facility. So early on in the process, the Health Sciences Building is being designed and built under a progressive design build delivery method. And what that did is it allowed KPFF to present this idea really early in the planning process for this project. So we were able to approach the contractor, the architect, and the owner and say, you know, here are the storm drainage requirements that would typically apply to this project. And here's something that we think would provide an enormous amount of benefit if we were able to do it. And so that's when we brought the regional GSI facility into question. And, you know, it was a great opportunity for us to look at the overall project schedule and the overall project budget and say, this is the time when we really need to start looking at it. So that's when we started the process of looking at all the pros and cons. If we were to look at this project on a typical project by project basis, and see what the pros and cons are of that compared to this regional facility. And these are some of the things that came up. Generally, you know, if you're looking at a project by project design, you've got new stormwater management, it's providing benefit. There's no agreement required with the city. It's done under the drainage code as written. And the costs up front are known and they're a lower cost. There are some cons associated with that, particularly from a campus perspective. The restriction of the design of the overall site, you know, if you need to put in bioretention planters next to the building, things like that, where the architect might want a little more flexibility. So then we started looking at this regional facility, and the biggest pro in everybody's eyes was the innovation associated with it. the more we looked at it, the more we could tell that the environmental benefit of this facility would be significantly higher than the standard project by project treatment. There would also be more treatment up front for the entire basin in terms of pollutant removal from the downstream system. So some of the cons, it occupies otherwise developable area on the university campus. There's also an agreement required. So the university had to wrap their brains around what the agreement might look like. And that's kind of the piece that we're really talking about together here, is that, you know, the innovation piece comes with some effort. And that was a piece that everybody had to look at and say, you know, what's does this agreement entail? And that's when we started talking with SPU and the city of Seattle and developing that partnership with them. So, you know, everybody had this common goal, and right now we're working through that agreement, and it's been a really educational and valuable experience for everybody to go through. And, you know, everybody loves data, and this has really been a powerful graphic in terms of explaining what this regional facility does for the downstream system in terms of the pollutants that it's going to remove from that system. So the green line below is a projection of how many pollutants would be removed over time if the university were to develop within this basin project by project and implement stormwater management tools as required by code. The purple line above illustrates the pollutant removal if we were to install this regional facility. And you can see that it immediately has a higher impact, and over time that impact just continues to grow. So then there's the educational side of things. You know, things really started coming together when we were planning this. We looked at the outfall for the basin and realized that it is adjacent to the Harris Hydraulics lab building, which is a civil engineering building. Outside, there's a concrete flume that used to be used as a lab tool. So they would run flow tests through it and conduct experiments through it. And right now there's a fence surrounding that, and it's been abandoned. It's got blackberries growing in it. And we looked at that and thought, well, you know, those are planter walls. If we clean this thing up, we're using low impact construction techniques. We're not going to dig a new hole. We can install the biofiltration material in this already built box and, you know, reduce the footprint in that way. The other benefit of this is that it's right next to the engineering building. We've already got some students that are helping us plan the locations of some monitoring ports so that they can continue to monitor the influent and the effluent of this system and compare the two and see what type of benefit this is going to have. So that's been a really fun piece of this, is to have the students involved, and they're really invested in it. It's literally right in their backyard. So that's been a really exciting piece as well.
Thanks, Puja. So I want to talk a little bit too about the collaborative approach that we're using for this partnership. I really wanted a cartoon that encapsulated all the joys of virtual work, and I think this one does it. There was another one that I found that had just people sitting around the table, and then one of them said, we need more cross-functional collaboration. Just make sure you bill each other's departments every single time you talk to each other, which I thought that one really hit home for the government employees, but I just wanted to name that, but that's a thing. But, you know, in all seriousness, it really does take a collaborative approach to make partnerships work, not just this partnership, but any partnership. You know, our team, it's a core team, but a lot of people make this work. You know, in addition to Puja and myself as the leads, we have a core team of folks with a lot of stormwater code expertise, a lot of design, GSI design expertise. We work with the Seattle Department of Construction and Inspections, who are responsible for drainage review. So it's really easy. I think it's important to know that it's really easy to get stuck in our silos and our, you know, sort of like the things that we defer to every day that define our work. But with a partnership, it's really important to recognize everyone's contribution. And I really appreciate how we've, you know, from the beginning sort of started going about this and doing, looking at this partnership and sort of leaning into the risk outside of the regular, sort of leaning on the regular everyday kind of regulatory stuff. I think a really important component to that is trust and leading with good intentions and being really honest and open with each other as much as possible. SPU has different drivers for our work. STCI has a different mandate. KPFF and the UW look at this in different ways, and that can make it hard to work through issues and sort of understand with a certain level of empathy what each partner wants to get out of this. So it's really important to build that trust and really focus on the sort of higher order thinking about, in the end, we all want the same thing. We want better water quality outcomes in Lake Union. This is a body of water that is important to everyone, starting with the tribes that were here first. Given the innovative nature of this project and the innovative nature of this design and working within the construct of the stormwater code, to try to design a better facility and do it at a regional scale, which for the green stormwater infrastructure hasn't been done as much as some larger sort of more gray infrastructure projects. So there's a lot of uncertainty with that and how we formalize this partnership. And as Puja mentioned, we're still working through some of the particulars of that, but we really see this as a win-win, and it's an opportunity as SPU is expanding our GSI program to really put some resources toward making partnerships like this work and to contributing to the advancement of the field and those community benefits. So that's been really cool. Okay, I think we're doing Q&A in the chat box, but that might finish it up for us. Ryan?
Puja and Brian, thank you. Yeah, we have real-time technical assistance going on with all these experts in the Q&A box at the bottom center right down there. I have one quick question before we move on. Awesome work. In a hyper dense environment, how much of a problem is it that this project is taking away somewhat significant amount of developable land? You did a good job of going through the pros and cons, but how much of a decision-making factor and difficult thing is it to take out this amount of land from urban development?
Well, I can take that one. So this facility will all be built on university-owned property. So that decision was really one that the university made. When we started looking at this, the university actually proposed this flume, this old abandoned flume, as a location where we might construct it. And they have a master plan, and this area is included in the master plan. And so we did look carefully at that to make sure that everything lined up. But it was really the university's decision to say, you know what, this is space we might be able to use for something else, but this has so many benefits in so many different ways, from the downstream system to helping our students, to helping the city educate themselves about what might happen next. And they really wanted to spend the time and the money both in building this, but also in dedicating this land to something that could really provide some long-term benefit to a lot of different people.
Awesome. Thank you for that. Continue to ask your questions in the Q&A box and get free technical assistance today, everybody, if you're on live. We're going to move on to our next presentation. For those that are on live, your Friday lunch break, just want to let you know we're going to likely bleed into about 10 minutes after 1 o'clock to get all this awesome content in. So let's continue on. We're going to hear from Brad Barnhart and Jonathan Halama next. Brad received his PhD in physics from the University of Iowa in 2011. Not sure we think of Iowa as being super progressive with green water, but we'll see. He's a former postdoctorate with the US EPA Office of Research and Development, and he has worked on watershed modeling applications throughout the Pacific Northwest for 10 years. Teamed up here, you're going to hear from Jonathan Halama. Jonathan's an environmental scientist working at the US EPA in Corvallis, Oregon. As a postdoc, he's also focusing on using spatially explicit modeling frameworks to help stakeholders better understand how land management actions could impact watershed systems at both the local and the bigger watershed scales. He also teaches spatial science in his free time at Willamette University in Salem, Oregon. Brad and Jonathan were eager to hear about some of this really interesting modeling that you've done.
Yeah, thanks so much. Yeah, so I'm Brad Barnhart. I was previously a postdoc with EPA, and so this work that I'm describing here is a project that I've done with Jonathan, myself, and then a number of co-authors listed here. Let's see if it'll... So this is just standard disclaimer we show for our presentations. Yeah, so this is basically an overview of our project. Our big idea is we want to use watershed models to simulate what would happen if you implemented really large scale implementations of green infrastructure. So our research question is, if we took every building in Seattle and covered it with a green roof, what would the resulting hydrologic discharge reductions be at a watershed scale? So really, you know, by using models, we're trying to look at kind of the upper limits of what can we expect in terms of implementation of green roofs. And just as a takeaway, we found that about 20 to 25% discharge reductions were capable when only covering 10% of the watershed area. So that's actually really promising for looking at like the big picture effectiveness of green roofs. I'm also going to advertise Velma, which is a spatially explicit watershed model. There's a number of different models out there, but Velma is pretty advantageous for a lot of different reasons, which I'll go into. But the latest model, Velma 2.0, was just released to basically include a lot of different green infrastructure capabilities, including green roofs. So on the right-hand side of this slide, you'll see the 4 watersheds that we targeted, Pipers Creek, Thornton Creek, Longfellow, and Taylor Creeks. And you know, Velma basically uses a lot of different input data layers such as elevation, soils, land use, and basically simulates how water will flow through these different land types to watershed outlets. And just one thing to note is that we found about 10% of these watersheds were covered in buildings. And even though these areas are, you know, in different parts of Seattle, they still had pretty much the same land use, land cover characteristics. So they're all heavily urbanized. It was just interesting that they came out so similar. And so this is an overview of our modeling setup. Velma works by basically simulating water flow through individual pixels. And that's shown on the left-hand side where water can flow through the soil column. And then that gets scaled up where you have many, you know, thousands of pixels where water can flow both vertically and laterally throughout the watershed. And if you can see, each of those 4 panels show a different scenario of implementing green roofs. So on the far right is everything's green. Those are all the building rooftops that were converted to green roofs in our simulation. So we looked at different scenarios of implementing green roofs. And so to jump to the results, you know, I'm skipping over a lot of the model validation that we did, but really the big picture results are as you implement more and more green roofs, you get larger annual runoff reductions. And these sort of max out at about 20 to 25% annual runoff reductions when you're covering every single roof with a green roof. We tested 2 different kinds of green roofs, extensive green roofs that have lower biomass and smaller soil columns, and then intensive green roofs which have thicker soil columns and can you know, hold much larger above ground biomass, larger plants and things. And so, you know, generally as a takeaway is that models are really useful. And one of the main, you know, advantages of using models is you can take sort of large or small scale results from case studies and then basically extrapolate them up to watershed scales and really large scales. So you can answer very large scale kind of big picture implementation questions. So to transition, we did this modeling work, but models are always dependent on what realism you incorporate into the model. And so Jonathan's going to talk a little bit about how we've taken kind of our current model setup and then improved it by incorporating some other aspects into the model. So we can switch over to Jonathan. Thanks.
Jonathan, you should be able to control the screen by clicking on it now.
Oh, there we go. Can you hear me?
Yes.
Trying to see if there's a delay or... Ah, I think I got it now. All right. So thanks. Yeah, I'm Jonathan Halama, and also been working within the Velma team, and leading off of Brad's segue there, this idea of green infrastructure and being able to, like in Brad's example, place green infrastructure on mini roofs. And then that led to this idea of, well, what about other types of green infrastructure and their placement? So the roof example, we're able to use roof data to guide the placement and then playing around with the level of green roofs. But then that kind of led into, well, what about other things beyond green roofs, like bioswales or microbial remediation or other forms of potential reduction of both water or having some type of water storage capacity, but then also how could we help mitigate contaminants? Because a lot of our work in our natural realms or natural water systems have to do with salmon recovery. And so moving from natural landscapes into urban landscapes was a bit of a challenge for Velma, but we've overcome it. And so I just want to play this video real quick to demonstrate how Velma functions, leading off of Brad's idea of having individual pixels that then build up to full systems and how they interact. So I'm going to play this video and pay attention to the end of October. Whoops. Plan. Trying to click, but I'm having trouble getting to the play button. Can someone hit play on that? It seems like when I click, it just moves to the next slide.
Yeah, let me try. Oh yeah, try that.
So again, watch for the end of October is the big action here. This is gonna be running October, November into December. Is the video playing?
It may not be
playing. Go ahead, keep going. I'll describe this real quick. So alder is a nitrogen fixer that will add a high level of nitrate into the soil, as much or more in a natural system than is put on the farm. So this is a watershed in the Equinox estuary system that is east of Newport. So if you've been to Newport, Oregon, this is just a little bit upstream from that area. And if we get the video playing, what you'll see is the yellow lines represent the major flow paths, and as there's an increase in water, those lines get, or those arrows get larger, representing higher flow. And what we hopefully will see at the end of October is that where there are alder, you have a buildup of nitrate in the system. And then when you have a storm event, that nitrate then starts to laterally move down through the system. And you'll see there's a little diagram there representing the hotspot. So this system of alder building up the nitrate then all funnels down into this certain point. So you get a very high spike in nitrate levels as it's moving into the marsh. Doesn't seem like the video works. So if anyone's interested in this video, happy to share it with anyone. We'll go ahead and...
We can add a link to that video either in the Q&A or when we post the YouTube video version of the presentation as well.
Yeah, we can do that. It's a really cool video. I recommend people watch. So.
And Jonathan, I'll share control back to you.
Thanks. Trying to see if I can, there we go. Oh, so then going from that natural system into urban systems after the green roof work, we realized, well, we have streets, we have impervious surfaces. Cari mentioned a lot of this in her presentation of how that water that would naturally get into the lower end of the system is no longer, there's some impervious barrier. And so we have pipes that reroute water. So if Velma is going to be doing urban systems, we somehow need to reroute the water. So here we're looking at a Google Earth scene then related to the Seattle Public Utility map on their interactive map online. And so looking at this, we found a great comparison. They had a great data set. And so we leveraged that data set to then understand, well, okay, where are the input storm grate locations where you'd see water going into the system? Where are the pipes going? And then ultimately, where's their outflow? So we built a Java-based code tool to work through this data and then format it in a way that our Velma model could uptake. And what ends up happening here is this is the Longfellow, or a part, not the whole Longfellow, it's a portion of the Longfellow, the northwest portion that is in West Seattle. This system is on the eastern side of West Seattle, so it's flowing towards the Duwamish. And so these blue locations are those storm grate inputs. We include the road system, so road wash is moving down towards those storm grates, and then all the reds are the outflow locations for this system. And so this is just a Velma representation of how we've translated the pipes and drains in the GIS sense from the Seattle Public Utility into something our gridded Velma model can understand. And the main target of our work beyond the 4 watersheds Brad mentioned was then for contaminants, Miller Creek became of high interest. And so that's the watershed we are currently working on, which is actually the upper end is the lower portion of the Seattle Public Utility. And then most of the system though is City of Burien. So here's just a map, member in our group, Vivian Fan, created for us. And it's just representing where we have monitoring of both flow and contaminants. Those are the sort of reddish little teardrop shapes. And then the little purple dots are collaboration with some of our other colleagues who have some other sampling location sites. And the blue dots are all of the inputs. And then you can't really tell where the outputs are in this map here, but, and then the black is all the road system itself. So this is the main watershed we're going to be looking at to seeing how we can help place green infrastructure and hopefully then be able to reduce, trap and reduce contaminants. And then the outflow from this will then hopefully help salmon species. And so to show how this matters in a modeling system, the a line of 0 would just be the natural state. So we're looking at the delta change in flow. And so having only the outflow locations be included is that blue line, that very low blue line. And so as you're running through, Velma's a daily model as it's progressing forward through time. This is a sort of representation of the hydrograph. And so the blue line is just representing some of the outflow locations only, but then including all of the input catchment locations and the curbs that flow the water to those inputs. That is the orange line. And so this is just a representation of how much change is occurring in the model. The model doesn't really think in CFS, it thinks in millimeters of water per cubic meter per day. And so these numbers look pretty low, 2.7, cut the graph down because there's a peak a little over 4. But in this system, in relation for 33 years of data, the max was 42. And so including these road systems curbs into our natural Velma model that's already capable of doing fate and transport of water and chemicals will really help us match the hydrograph a lot better in urban systems. So to conclude, this framework provides us an ecosystem service tool people can use to estimate green infrastructure management across whole watersheds. And the framework considers both the natural system, which is what Velma was really built for, but now we included streets and storm drains and can include existing green infrastructure, but also add hypothetical green infrastructure. And this holistic watershed approach using green roof infrastructure and the fate and transport of chemicals in a natural system will be very helpful for people understanding how various types of management activity to help mitigate some of these problems will help our communities in the future. References. Thanks.
Thank you, Brad. Thank you, Jonathan. Super interesting, cutting edge thinking and work. I am curious, with the model in place, how specific is it to the Seattle area that you showcased for us? How applicable is it to communities outside of Seattle, outside of the Northwest? And do you envision taking the modeling work to a community outside of Seattle soon?
Yeah. You want to fill that, Brad, or I can fill it?
Yeah, go ahead. Go ahead, no problem.
Yeah, so in the natural system, Velma has been applied to areas in the Chesapeake Bay system, other watersheds in Washington, a lot of work in Oregon, Northern California. So in a natural sense, it's been applied to many different systems. It's a very transferable model. So once you have a setup and calibration, you can move it around pretty easy with no to minimal change to your setup. And then beyond that, there's been talk of sites in Mobile Bay and also in Duluth, Minnesota area. They're both interested in this green infrastructure work. And those are directly through other EPA labs that we've been working directly with. And we have a lot of partnerships in the Seattle area. So there's a bigger potential work here for the entire Salish Sea of running it on systems all the way from Olympia all the way to Bellingham potentially. So
awesome.
These are the only green infrastructure projects we're currently actively working on.
Well, thank you for sharing, gentlemen. I know there'll be a lot more questions in the Q&A chat about using the models that you've developed. So thank you for sharing this great knowledge. A lot of work goes into it. Our final presenter today is someone I often call the Queen of Puget Sound. She has really helped move a lot of governments and NGOs in alignment and is just a woman of action. So Jessie is the Nature Conservancy's Puget Sound Conservation Director. And in addition to leading the Nature Conservancy's work to clean up and restore Puget Sound, she's also the chief architect for advancing TNC's work in urban areas. We think about TNC in far-flung areas, but they're right here at home doing amazing work in urban areas, helping to make our communities resilient in the face of climate change impacts. And really, Jessie has been a leader in both the public and private sectors for over 2 decades. Jessie, I'm excited to hear some actionable steps that you're going to be sharing with us. Go ahead.
Yeah. Great. I'm looking. So thank you. I'm going to talk a little bit about the Water 100 project, which is a new project that I am collaborating with Puget Sound Partnership on. And this effort is really came out of a mobilizing funding plan that Puget Sound Partnership developed to try and build other types of non-public funding for Puget Sound recovery, and work that I had done around corporate engagement with Boeing and other corporations to try and figure out how we could get them to invest more in Puget Sound recovery. And I'll say this work is was really inspired by from a couple of different places, and it's a mashup of work from a bunch of different places. I spent the past 5 years sitting down with a lot of corporate leaders and asking them, what would it take for you to get some skin in the game on Puget Sound recovery? And the first time that the book Drawdown by Paul Hawken was referenced, I thought like, oh, how interesting. The second time I thought, gosh, maybe I should read that book. By the third and the fourth time the book Drawdown was mentioned, I thought maybe I should learn from this. If this is how corporate leaders think about how to mobilize funding for environmental action, then maybe there's something to be learned from it. Boeing, along with Puget Sound Partnership and my colleagues around the country who work with the UN Global Compact CEO Water Mandate, have been wonderful in helping us to co-create this vision. The vision that we're trying to pull together and the goals that we're trying to pull together are really about building a movement with business in close coordination with NGO community, scientists, engineers, and public entities, inspiring commitment to take urgent performance-driven action, celebrating case stories of investments in the most impactful solutions, and then taking all of those impactful solutions, harnessing the data from pilot projects, and hopefully quantifying and ranking the top 100 most substantive solutions we see for a clean and resilient Puget Sound. We spent some time in the beginning of this effort, I think it was back in the fall of 2019, pulling together a group of scientists, and I'm sure several of them are on this call right now, pulling together a group of scientists to say, like, what are the 100 biggest solutions for Puget Sound? We came up with a long list, certainly more than 100, and ended up divvying them up into 9 sectors. I'm going to show you some of these 9 sectors and some of the solutions that were proposed. They look a little different than how we talk about solutions for Puget Sound recovery. We were lucky that Boeing happened to have Paul Hawken, the writer of Drawdown, on retainer for another project. So he was able to lend some advice early on for this effort and say the positive framing is really important. The positive framing he did with the book Drawdown really helped it to resonate with the private sector and inspire action and build a movement. So if you've read the book Drawdown, you'll see rather than saying stop coal-fired power plants, it says, it takes the opposite, which is increase renewable energy production. We tried to do the same, and each solution you're going to see here today really uses positive framing, and it is intended to focus on the outcome of a clean and resilient Puget Sound rather than restrictions, prohibitions. Right now, we are scoping an approach to model and rank these solutions and borrowing expertise from engineering, performance management, life cycle assessment, and water footprinting. The 9 solutions you'll see here that I can scroll through, if I can get this to move forward, there really is a delay, are pulled together. Let's see. Are pulled together. I'm going to go back to land use and some of these other. Are pulled together, and a lot of the examples that you heard from the colleagues, my colleagues on this webinar, are actually in this list somewhere. Industrial area stormwater solutions, neighborhood scale stormwater facilities, building decision support tools that rely on big data. These solutions are the solutions that the folks on this call are really trying to implement every single day. They are the solutions that you'll find in the Puget Sound Action Agenda. They're the solutions that the nonprofits associated with city habitats and stewardship partners are working on, and they really cross sectors. And we try to really think expansively about what are the things that impact Puget Sound recovery well beyond just green stormwater infrastructure, and think about what are the actions that cross both urban and rural areas, water quality and water quantity. As I said, our goal is to start to do the work to really build out case stories of innovative pilot projects for each of these solutions over the next several years. And I'll say the thing that I'm most excited about are the enabling technologies and coming attractions. And this is an area where I think that we could all really dig in a little bit, dig in and look for places for pilots that could potentially change the course of how we recover Puget Sound and buy down the cost of recovery significantly. All of these solutions are on, if I'm going too fast for you, they're all on the Water 100 Project website, water100project.org. I'm going to give, I know I don't have much time, but I'm going to give you a couple quick vignettes about what some of these solutions look like in a practical way. And some of these case stories are going to be very familiar to this group. This is a case story about the Boeing Company and Washington State University coming together to take carbon fiber waste from airplane production and integrate it into permeable paving to increase the tensile strength of permeable paving. It's a fantastic project. There's more information about this case story on our website, but it's a really fantastic example of a private sector partner and a public sector partner coming together and mobilizing funding from both sides to develop an innovative pilot that really is intended to increase and accelerate the pace and scale of recovery. A more rural focused project is a project between Janaki Industries and the Stillaguamish tribe that the Nature Conservancy has helped out with to build a machine that will treat dairy waste and turn it into clean water and other revenue producing products. It is currently, TNC just produced a video that you hopefully folks will see soon about this effort that you can see on the project website. It's a great example of Janaki Industries is a company out of Cedro-Woolley, Washington that is led by Peter Janaki. And Peter was approached by Bill Gates a few years ago about the issue of water and sanitation in the developing world. And Peter's a rocket scientist. He builds pieces of satellites and parts for NASA out of his Cedro-Woolley Janaki Industries shop, but took the problem of health and sanitation and water and sanitation as a personal challenge and developed a machine that the Gates Foundation built and is using in the developing world. A dairy farmer out of the Nooksack Valley, out of the Nooksack in Whatcom County, saw some information about this project and said, hey, if we can treat human waste in Senegal with the machine and turn it into clean water, can't we do something about the dairy waste in my own backyard? I mean, Cedro-Woolley is literally one of my neighbors. So it was a really great question, and a question we took to heart, and a coalition came together, and the machine that's being developed is really pretty extraordinary. Stephen Gray and Associates and others, many of whom are on this call, KPFF, Weber Thompson, Tableau, Salmon Safe, and others have come together to retrofit the Aurora Bridge with green stormwater infrastructure on private land. And this would, if folks remember when during the City of Seattle presentation, we were talking about that gray bar on, I think it was Brian's graph, about to be determined, how non-regulatory stormwater that needs to be treated through public-private partnerships, but we're not quite sure yet how it's going to get treated. And it was about I think a couple 100 million gallons that we still had left to figure out. This is a great example of how public-private partnerships are coming together to deal with that little gray bar. This project has led to another project that the state is now funding underneath the I-5 Ship Canal Bridge with the goal of treating 98 million gallons. So 100 million gallons treated in one single project through an innovative public-private partnership. And Vulcan Real Estate, who was challenged by their owner, the late Paul Allen, to think about how all of Vulcan's business units were challenged by the late Paul Allen to think about how they could impact water in a more progressive way and use the power of their businesses. The real estate arm of Vulcan really embraced Salmon Safe, was an early adopter embracing Salmon Safe certification in many of their South Lake Union office buildings. That engagement with Salmon Safe and doing it on site for their facilities started within their organization and movement, but then they required all of their contractors to also use Salmon Safe and become Salmon Safe certified. And then when they realized they could actually use the power of their organization to go further, they then developed the world's first Salmon Safe accredited developer program. And they created this from scratch and is now being piloted around the world. All of these are examples of innovative technology pilots and pilots for innovative approaches that are being leveraged for public-private partnerships, through public-private partnerships, to really break the mold for how we do this work. I'll say you can't just jump. One of the things that I've learned over the past few years in doing this is you can't just jump to an innovative pilot. We definitely defined and fund these technology pilots, but before that, you have to back in by building an understanding about what are the customer needs, the utilities, the landowners, the conservation districts. What are the customers' needs and challenges and opportunities? And how do you incubate solutions that may be able to deal with those solutions? This graphic I have on this slide is from our Nature Conservancy Sustainability Accelerator out of our Denver office, where we're incubating startup companies that have the potential of having commercially viable technologies. There's some companies in this list that you may be familiar with. Storm Sensor is a local company that's really doing great work. Jibe, Second Nature, or other great, Nori is another local company. These types of technology accelerators are really helping bring new tools. But again, even before you have new tools, you have to back up again and really inspire the customers, or kind of the receiving ground, to figure out how do you get organized to deploy these solutions in a rapid way. The Nature Conservancy and my team are starting to really use the Google Ventures approach to, we call it our Agile Labs. So using Agile as and a sprint process to help communities through mapping assumptions, sketching out ideas, developing prototypes, testing those prototypes, and doing that on paper until we can get to an iterative place where we can actually do technology pilots. And all of this work with Water 100 for these 100 solutions are designed to be able to help us learn, build, measure, and then start that loop over again. We know that the first pilot that we fund is not going to be perfect. And in fact, the first few pilots that we fund may fail. And failing is actually a good thing, that as long as you learn from it and apply that learning to your next time around. So we're really trying to build a culture where let's fail forward and try some stuff out and build 100 technology pilots for the 100 highest impact solutions for Puget Sound recovery. In all of this work, we're trying to engage the private sector. we have on our webpage, we'll be launching a Puget Sound Clean Water Pledge for the corporate community. And this corporate Puget Sound Clean Water Pledge is really about engaging private land, private dollars and private voice, and private expertise, and to help us build these technology pilots together. I know I cruised through that information really, really quickly, but I appreciate folks sticking around for the last few minutes as we went over, and feel free to reach out or get on our webpage and find out more.
Jessie, awesome. I'm glad we finished with you today for these inspiring stories. One quick question before we let everybody go. You mentioned that in the Hawkins example of drawdown, they actually not only came up with the actions, but they ranked them.
Yeah.
So you knew which ones were more impactful than others. Is that a possibility for this 100 project related to water?
Yeah, that is actually, if you can, Aaron, go back to my slide deck, that would be great. That's actually something that I think I have a couple slides here that might be able to. So Paul Hawken did rank his, and I'll say, words you never thought you would utter. Water makes climate change and greenhouse gases look really easy. The cool thing of drawdown is they ranked their list by CO2 equivalent and then went through, and you can see that they ranked them. So reducing food waste, like promoting, building more forest, which I think people think about a lot when you're thinking about climate change. It actually ranked 15th. Rooftop solar, which we talk about a lot when we're talking about climate change, ranked number 10. Reducing food waste, ranked 3rd in things that you can do that have the potential to change the course of greenhouse gas reduction. Number 6, something nobody talked about until Paul Hawken wrote this book, is educating girls. Number 5 is family planning for women. When you talk about ranking a list for greenhouse gas reduction, you are normalizing for one factor. When you're talking about water, you're talking about water flow, pollution, fresh water, salt water. We're fortunate that there is a methodology out there that we can borrow from in water footprinting, and we're working with a group of scientists and experts from the University of Washington and engineers to really think about what it would take to do a water footprint analysis for all of these 100 solutions that took into account kind of the surface water and groundwater from a quantity perspective, rainwater from a quantity perspective, and pollution. And it's really complicated. If anybody wants to help work on this and scope this science effort with us, we would love to have help. But we're on a path.
Awesome. We definitely need an everything above kind of strategy, but we can't do it all at once. So understanding what is more important than others certainly is helpful when we have limited time resources. Thank you, Jessie. If I had I should have gotten a recording of like a Seahawks game cheering, because I would play it right now to cheer for all of my fellow panelists. Gratitude to all of you for your thinking, sharing your thinking, and preparing for today. Thank you to everyone who took the time to listen in. I'm going to send it back to Aaron at Stewardship Partners to close us out.
Great. Thank you, Ryan. I want to thank all of you for being on this presentation today. I want to thank all of our speakers. I mean, there are so many themes that really resonate, that really connect to what this whole city habitats network has been created for, about connecting the dots. No one sector, no one organization, no one company can do any of this alone. And so that collaboration and cooperation is so key. Connecting the dots, the .coms, the .orgs, the .govs, the .edus. That's what this summit is about. That's why City Habitats was created. And that is exemplified, I think, in all of these presentations. I want to just encourage everybody to remember next week, we've got 3 more sessions coming up, Monday, Wednesday, and Friday. On Monday, we have, it is Clearing the Air, Communicating the Benefits of Green Infrastructure. It is going to be a fantastic session. I encourage everybody to tune in. That one is scheduled from 1 to 2. And as we saw today, there's a chance it might go a little bit long, so you might want to hold a little extra time at the end. As we're coming up on 1:30 and having gone a full half hour extra, I don't think we will do any Q&A with the audience, but feel free to reach out to us at Stewardship Partners if you have questions. We'll be happy to connect you with speakers or answers that we may have ourselves. And with that, we'll send, there will also be, this video should be up on YouTube, possibly over the weekend or Monday. Our session on Wednesday is already up and live on the Stewardship Partners YouTube channel, so check that out. And with that, just many thanks. That was excellent from all of you. So until Monday, everybody have a great weekend. Stay safe out there. Be well.